Hi, my name is Ramaisari binti Hassan. So next is an introduction. So HPLC is a form of column chromatography that pumps at a high pressure a sample, and which is analyte, dissolved in a solvent, which is mobile phase, through a column with an immobilized chromatographic packing material, which is known as stationary phase. The properties of the sample and the solvent, as well as the nature of the stationary phase, determine the retention time of the analytes, or how fast they pass through the column. As the sample passes through the column, analytes having the strongest interaction with the stationary phase exit in the column the slowest, meaning they exhibit the longest retention times.
Next, methodology. Sample preparation. 21 honey samples were prepared. 30 samples from the regular shopping network, 2 samples from purchase of the healthy food stores, and 6 samples from the local beekeeper. Second, 10% of the solution prepared from the relevant samples of honey. Third, after mixings, 2 parallel samples were prepared. Fourth, centrifuge at 18,000 rpm for 5 minutes and analyzed by HPLC. Next, conditions of analysis. Column, still 7.8 300 mm. For the temperature, 80 degrees Celsius. For the mobile phase is deionized water, flow rate 0.8 milliliter per minute. For the injection volume, 5 microliter, and for the pressure, 2.6 MPa.
For the analysis of for HPLC, in the case of this analysis, properties of mobile phase such as the percentage ratio of acetonitrile and water have vital roles in controlling the retention time. Therefore, a different mode of gradient was applied to allow the strongly retained analyte to be eluted quickly, thus reducing the column length and produce better peak and reduces the retention time. Amongst amounts of fructose, glucose, sucrose, monosaccharides, and oligosaccharides were detected using HPLC method. Using this HPLC method, each honey sample can be analyzed whether it can be intended for human consumption or otherwise. According to a research by Kamal and Klein, it is based on its linear regression analysis. It could be found that fructose and glucose were found as 1.605% and 1.08% in the sample of honey. To conclude, the honey is mostly composed of monosaccharides.
In conclusion, the HPLC method was used to determine the amount of fructose, glucose, sucrose, and oligosaccharides in sample of honey. The most common in evaluating the compliance with labeling requirements was the absence of honey type identification, while honey adulteration usually does not endanger consumer health because of the practice deceive consumer. Existing legislation provide for the evolution of honey rather inaccurately, as it does not define the generic status of honey, does not distinguish between flora and honeydew honey, and does not limit the use of the word forest in labeling of honey. So that's all for us. Thank you.
Next is an introduction. So, spectrophotometer is used to measure light intensity as a function of wavelength. So, spectrophotometer does this by diffracting the light beam into a spectrum of wavelengths, detecting the intensities with a charge coupled device, and displaying the result as a graph on the detector and then on the display device. In the spectrophotometer, a prism or grating is used to split the incident beam into different wavelengths. By suitable mechanism, wave of specific wavelengths can be manipulated to fall on the test solution. The range of the wavelength of the incident beam can be as 1 to 2 nanometers. The spectrophotometer is useful for measuring the absorption spectrum of a compound, that is, the absorption of light by a solution of each wavelength.
Next, for the methodology, sample preparation. First, 75 ml ethyl acetate, 60 ml acetic anhydride, and 21 ml concentrations of H2SO4 were pipetted to the volumetric flask at 0 degrees Celsius. Second, stirring for 10 minutes and stores into the fridge for 3 hours. Third, to the prepared LB reagent, 1 ml sample solutions was added. Fourth, after 5 minutes, absorbance value was recorded and at 625 nanometer for 20 minutes. Lastly, the concentrations of the cholesterol in the samples was calculated from the calibration curve, which was performing using calibration standards. Next, conditions of analysis. The detection wavelength was 625 nanometer by using spectrophotometer carry 300 UV-Vis.
Based on the results, the spectrophotometric measurement was optimized regarding the results. 30 minutes of reaction time is the optimum time for the spectrophotometric method. The reaction time less or more than 30 minutes will cause different absorbance measurement to be collected and thus resulting in an inaccurate result to be formed. Cholesterol is oxidized in the presence of a conjugated pentene, which is known as cholesterol sulfuric acid carbonium ion. A similar wavelength of 640 nanometer is used for the determination of cholesterol in some commercial edible oils. From the results, it was thus obvious that the LB color reagent is stable. The reaction is also influenced by the stability of cholesterol solution. Based on the analysis, a high solubility of cholesterol shows a low efficiency of fat extraction, and hydrophilicity was detected using the spectrophotometer method. Spectrophotometric determination of cholesterol content was based on the Lieberman-Bouchard reaction among cholesterol, ethyl acetate, acetic anhydride, plus concentrated sulfuric acid, and the measurement absorbance of foam color at 625 nanometer.
In conclusion, this study was focused on the spectrophotometric determination of cholesterol. The spectrophotometric determination is influenced by the stability of adsorbent characteristic of LB reagent. The results obtained from spectrophotometric determination differed in this method is suitable for analysis of cholesterol. So that's all for us. Thank you.